Hello, friends. Welcome to another session on Quant. So, I am Orko if you are visiting this channel for the first time. So, what we do here, we talk about quant topics that are relevant for your CAT, NMAT, SNAP, IFT kind of exam. As part of that, in the last few videos, we are talking about number system, which is, a very, very important topic on your any MBA entrance exam. So, it's a little uh, yeah, complicated area. I'll say not a complicated one, but it's a little complex in a way so that there are multiple concepts you need to understand. And possibly you are doing something like a topic dedicatedly to number system first time when you are preparing for CAT. Some of you may have done it before. Most of you, it will be a new. So what we did till now, we have covered all the concepts around a series of 7 to 8 videos. I'll put all of them in the description box. So that is what we have done till now. And so first go through those. And then what we did three focus session on problems. And this is the fourth session on problem solving on number system. So together, these 12 videos will help you master the number system chapter completely. And I can assure you, you will be able to solve most of the problems if you follow this 12 sessions. The only suggestion or a disclaimer here is if I'm solving 7 to 8 problem in a session, you should go back and do at least 20 to 25 problems at home. So at least 3x problems at home, you have to practice. So in each of the 4 sessions, if we together covered around 35 to 40 problems, then the idea is you go back and solve around 90 problems at home on number system. Anywhere you feel in doubt, you can drop me a comment section and I'll be able to respond. Or you want me to reach out to my mail ID that is given also description in the description box. You can reach out to me directly. But yeah, do spend that hour at home, sweat it till you get it completely. So that amount of problem solving practice is very much required. Otherwise, you will not be able to train your mind muscle enough so that once you get a number system problem, you can solve it. So with that, let's get started with the last problem session on number system. I'll put all the concept and the previous problem sessions video in the description box. You can have a look. So what's the first problem says? It says a teacher wrote in consecutive natural numbers starting from 1 on a board. So basically, he is writing 1, 2, 3, 4, and all that natural number. One of the students erased one of the integer. I don't know which integer. The sum of the remaining integer is 4035. Okay, so that means let's say the teacher has written till n integer and nothing has been erased. So what will be the ideal sum? The ideal sum will be n into n plus 1 by 2. If all the numbers are given, 1 plus 2 plus 3 plus 4 till n, the sum from the AP tells you this will be the sum of the series of natural number where the numbers are consecutive. So then this is the sum. So n into n plus 1 by 2. Now, they said that person has erased one number. So let's say the number they have erased is x. The integer is x. So then can I write n into n plus 1 by 2 minus x? This is 4035. So 4035 is not the sum of all the natural numbers till n, or they have given capital N. So I have taken small n. So your capital N in the question is same as small n here. And you are finding the small n. Instead of writing capital N, I'm just writing small n. So if I subtract x from the sum, I will get the 4035, the sum of the remaining integer, which is 4035. So with that, so this is what we have to figure out. Now, if you see, what does x means? X means n into n plus 1 by 2 minus 4035. Just changing the sides. Now I know x has to be greater than 0 because x is an integer and a natural number. So x has to be greater than 0. If this implies, then can I say n into n plus 1 by 2 must be greater than 4035? It has to be greater than 4035. Otherwise, it will not be possible for a natural number to, if n into n plus 1 by 2 is not greater than 4035, your right hand side of this equation will become less than 0, but x is greater than 0. Okay, so let's see. So then can I say n into n plus 1 must be greater than 8090? N into n plus 1 must be greater than 8090. Now, let's see what is the value of n has to be. So I know if you do n into n plus 1 is 8090. So if I, let's say, for take 80, n as 80, 80 into 81 gives me what? 81 is a 0, 8 in hand gives a 640 plus 8, 6480. So very far till now. Let's take another scenario. Let's say n is 90. So 90 into 91. 91s are 90, 9 in hand. 99 is a 810 plus 9, 819. So 8190. I get n if 90 and n plus 1 is 91. I will get n into n plus 1 as 8190, right? 8190. Now what will happen if n is 89? Let's see. If n is 89, this will become 89 into 90. Let's see how much it becomes. So 99s are 810. So 0, 81 in hand. 98s are 720. 720 and you have 81 in hand. So you have 801. No, sorry, 800. So just a minute. Let's do it in the space. So what I'm saying is, let's consider n as 89. So it will become 89 into 90. So 99s are 810. 0, 81 in hand. So 9 8s are 90 into 8, 720 plus 81 is 801. So 8010 I get, my value is 8090. So n equal to 89 also does not satisfy the condition. The condition satisfies when n is equal to 90. When n is equal to 90, that's when the condition is satisfied. Now, what is the value of x? So the value of x will be 90 into 91 by 2 minus 4035. So 8190 by 2 minus 4035. So this I will get 4 0 9 4095 minus 4035. So the answer is 60. So 60 is the answer of x. So the number that has been removed is 60. Okay. So now answer. So there's an n consecutive natural number was given. One number is removed. How you find the number? You kind of create a condition inequality and then see for which minimum value of n that will satisfy. Okay. So this is what we got till now. Okay. So go to the next problem. So hope you understand the previous one. If you have any doubt, please feel free to reach out. So this is a recap kind of a problem. We know n equal to 3 to the power 6, 2, 7, 5 to the power 11. I'll do it for 24. You can do it for 90. So find the number of factors of n that are multiple of 24. So how many factors of n has n equal to 3 to the power 6, 2 to the power 7, 5 to the power 11. So that means factors, or the number of factors, I'll say number of factors for n will be 6 plus 1, 7 plus 1, 11 plus 1. Recap of your factorization concept video. You can go back and see the video how we calculate, but it's basically the sum, the power plus 1 and multiplication of the same thing of all the powers. So 7 into 8 into 12. So you know now 56 into 12 and then 2, 7 in hand, 60 into 7, 67. So these are the number of factors of n. And what they said, how many of them are multiple of 24? So to get a multiple of 24, what is 24? 24 is nothing but your 3 into 2 cube. 3, just a minute. your 24 is nothing but 3 into 2 cube. So if I write 3 into 2 cube, if I segregate 3 into 2 cube from this, the rest is basically all the multiple of 24. So let's say I take out 3 and 2 cube, then what I have in between is 3 to the power 5, 2 to the power 4, 5 to the power 11. So this is what I have in between. Now this is if I what I have in between, then this part is a this is 24. So everything that is there inside, all of this will be a power of 24. So sorry, multiple of 24. So how many of these are multiple of 24? We can say all these factors. So again, number of factors will be equal to 5 plus 1, 4 plus 1, 11 plus 1. That means 6 into 5 into 12. That means 30 into 12 or 360. There are 360 factors which are multiple of 24. Because I have taken 24 outside, the everything that is left over will be a power multiple of 24. 360. So similarly, you can do it for 90. It's the same approach. And try that problem and drop the answer in the comment section. I'll be able to confirm and then see how many of you get it right. Let's move to the next problem. So it says find the remainder when 1, 2, 3, 1, 2, 3 up to 450 digit is divided by 999. Okay. So when this kind of problem appears, don't get overwhelmed by the type of problem. Think logically and try to break it. Okay. So whenever we do remainder, what is our one point of approach is try to get a number in numerator which is +1 or -1 away from the denominator or the number that you are getting you are using to divide the numerator. So +1 or -1 gap you should be creating also. So in this problem, let's say 1, 2, 3, 1, 2, 3, 1, 2, 3, and then there is a pattern till 450 times. So can I group them together? So this is one group, this is another group, this is another group. So how many of this group I will have? I will have 150 of such groups. So 1, 2, 3, 1, 2, 3, then like this I will have 1, 2, 3, which is 150th. Right? I'll have 150 of this group because if I'm taking 3 digits at a time, I will create 150 groups of 3 digits because there are total 450 digits. So 450 by 3 is 150. So I'll create 150 of such groups. Okay. Now all this will be divided by 999. Okay. Let's see how we can break it further. Now, before I continue with this problem, let's solve a foundational understanding. So if I have a number, let's say 100, or let's say not 100 will be easy. Let's say I have a number 435. How I can write that number? I can write that as 4 into 100 plus 3 into 10 plus 5 into 1. So I can very well write this number as 4 into 100, 3 into 10, plus 5 into 1. So 4 into 100, I can write it as 4 into 10 square, plus 3 into 10 to the power 1, plus 5 into 10 to the power 0. Right? 5 into 10 to the power 0. Now, let's say there is a 4-digit number. Let's say 1, 2, 3, 4. How I can write? I can write 1 into 1000 plus 2 into 100 plus 3 into 10 plus 4 into 1. The same way I can write 1 into 10 cube plus 2 into 10 square plus 3 into 10 to the power 1 plus 4 into 10 to the power 0. Right? So this is the way we can write. So if there is a number of 5 digit, let's say 5, 6, 7, 8, 9, can we write this as 5 into 10 to the power 4 plus 6 into 10 cube plus 7 into 10 square plus 8 into 10 to the power 1 plus 9 into 10 to the power 0. So we can write it like this if there is a 5-digit number. So the idea here is, why I'm telling you all this, because if you understand how all these numbers are written and think this is as 1 digit. Okay, this is the second digit. And then there will be 150 such digits. So what I'm trying to think is, consider 1, 2, 3 as a group as a single digit. So you will have 150 such digits. If you have 150 such digits, like in this case, there are 5 digits. The first one is multiplied with 10 to the power 4. In this case, there are 3 digits. The first one is multiplied with 10 square. In this case, we have 4 digits. The first one is multiplied with 10 cube. So in this case, can I write this as the first one, say 1, 2, 3 into 10 to the power 149, or sorry, 3 digits I'm taking at a time, so it will be not be 149. So 1, 2, 3, 1000 to the power 149. Now you may ask why I am taking 1000, because I am taking 3 digits at a time. So all the 3 digit should be your should be considered, because these are, from my understanding, I'm considering all 3 digits as one group, but the whole group has to be multiplied with 1000. Why 1000? Because if you see here, you are taking 1 digit at a time, so you are anyway multiplying with that with the number of digit you have. So basically, if you are taking from 435 1 digit only, then you can multiply that with 10 to the power 1, right? Or if you are taking 1 digit at a time, then you can multiply this. How many zeros should be there? There should be 1 0. So this is 10 to the power 1. So basically what I'm trying to say is, if you have 123, this first 123, I can write this as 123 into 1000 to the power 149. Why 149? Because you see, it always starts with 1 power less than the number of digits. So if there are 150 such groups, so the first group, it will be 123 into 1000 to the power 149. Then in the second case, it will be 123 into 1000 to the power 148. Then so on. And the last, you have 123 into 1000 to the power 0. Right? 1000 to the power 0. All of this divided by 999. So in each case, the first one will be divided by 999, and how much it will give? Just a minute. If I divide the first one by 999, it will give me a remainder of 1, because 999 by 1000 gives a remainder of 1. In the first case, you get a 123. In the second case also, you get 123. Okay, so like that, you get 123 as a remainder. You get 123 as a remainder 150 times. So can I say this is nothing but, the remainder is nothing but 123 into 150 divided by 999. Okay, so what I'm trying to say is 123 into 150 divided by 999. Now if you do this again, you will be able to see is 450, 45 in hand, 300 plus 45, 345, 34 in hand, 150 plus 34, 184. So you have 184 by 999. Now again, what I can do is, I can make it as 18 into 1000 divided by 999 plus 450 divided by 999. So basically 18,450, I'm breaking it into 18,000 plus 450. So 18,000 is 18 into 1000. So from the first one, I'll get a remainder of 18, sorry, 999 by 1000 gives a remainder of 1. So 18 into 1, 18. plus 450 by 999, I'll get a remainder of 450. So the final remainder will be 468. So this is a very, very good problem. What you need to understand is how we did it step by step. So first we bucketed it all 3 digits at a time. So make 150 such groups. And then we applied the logic of power, breaking up each digit and thinking them, each of the group is 1 digit. So first group is 123 into, since you have taken 3 digits as one group, it will be multiplied with 10 cube or 1000, and then to the power 149. How we got 149 is the right side examples. So every number, if you break it into smaller digits or the sum of the individual digits, then every number starting from the beginning, it will be multiplied with 10 to the power 1 less of the number of digits. So like you said, 1, 2, 3, 4, first is 1 into 10 cube. 4, 3, 5, first is 4 into 10 square. 5, 6, 7, 8, 9, first is 5 into 10 to the power 4. 4 is 5 digits minus 1. Similarly, this will be 149. And then the next one is 148. The last one will be 0. So we get all the thousands divided by 999. I get the remainder as 1. So 123 into 1 to the power 149, 123 into 1 to the power 148. So all the places I'll get 123 as the remainder for 150 times. So this is 150 times. So then I'll get 123 into 150, which is whole divided by 999. This is the remainder from the given one. Now this 18,450 is more than 999, so this cannot be a remainder. Again, divide this whole by 999. I divide by between 18,000 and 450. Again with 18,000, I get 18 as a remainder. And then 450 is anyway less than 999. So 18 plus 450 gives you 468. A very, very good problem. Please put a star mark on this. Any doubt, please feel free to reach out. Okay, let's go to the next problem. It says the remainder when 121 to the power 141 is divided by 29. So I know 121 and 29. Okay, 121 and 29 both are co-prime. So from the Fermat's principle, what we know in the remainder theorem, and you can go to the last session, last concept video of number system, which is around remainder theorem. It says if m and n are co-prime, then m to the power n minus 1 divided by n will always gives a remainder of 1. So the remainder of this part will always be 1. Remainder of m to the power n minus 1 by n equal to 1. So 121 and 29. So I can say 121 is basically my m, and 29 I can say is my n. But I know the power of 121, which is 141, is not 29 minus 1, but it can be made. How? Let's see. That's the crux of the problem. 121 to the power 141, remainder of this divided by 29 is same as writing remainder of 121 to the power 140, because I know n minus 1 is nothing but 28. So 28 has a power, higher power of 140. 28 into 5 is 140. So I'm just trying to get it there. So 29 into remainder of 121 to the power 1 by 29. So then I had 141. So I break it into 140 plus 1. Okay. So in this case, I can write 121 to the power 28 by 29. So 140 ko I'm breaking into 28 times 5 into remainder of again 121 to the power 28 by 29, and so on. I do 5 times, and then I have remainder of 121 by 29, which is this one. Okay, so I break 28 into 5, which is 140. So for each of these 5 times, I will have 1 into 1 into 1 into 1 into 1. 5 ones as a remainder by applying this formula. Okay. So by applying this formula, and the last one gives me 121 as a remainder. Sorry, not 121, 21 divided by 121 gives me how much remainder? 29. If you do 29 4s are 116, so 5 as a remainder. So your total remainder will be 5. So 121 to the power 141 divided by 29 gives you 5 as a remainder. So see how I have broken, which is not, looks like an exact replica of the formula. They will not give you where you can directly apply the formula and to think and break. Okay, 29 is n, so n minus 1 is 28. I need somehow 28 into the power. And how can I can make it 28 into 5? So make 28 into 28 into 20, 28 plus 28 plus 28. And then 1 is left. I'll take that separately. So this breaking down of the problem and apply the formula is basically what you need to practice. So like I said, when you practice these problems at home, you will be getting more and more finer at identifying how to break the power, how to make it align with the formula and apply it. Okay, let's move to the next problem. Let's find the remainder when 14 factorial is divided by 17. So again, before we go, we know the normal, this is the Wilson theorem. Again, I may not have used the same name, but the same formula I have taught you in the remainder theorem session of concept video. So it says the remainder of n minus 1 factorial by n is, oh my, think on this. So remainder of n minus 1 factorial by n, if you have gone through that video, take a minute, think, and then I'll write. So this is basically n minus 1. Similarly, what we know, remainder of n minus 2 factorial by n, the remainder is 1. The only condition here is n is a prime number. Okay, so this is what we know till now. Now I know in this case my n can be 17. So this is a prime number. So can I say remainder of 16 factorial by 17 is 16 by applying this formula? Now what I need to find out is 14 factorial. Now if I have to find out 14 factorial, I can break the 16 factorial into 16 into 15 into 14 factorial, all by 17 is equal to 16. So 16 into 15 into 5, then write 14, 13, 12. The 14, 13, 12 till 1 is basically a 14 factorial. Now if I know that, then it is 16 into 15 into 14 factorial. So then I can individually calculate. So remainder of 16 by 17 into remainder of 15 by 17 into remainder of 14 factorial by 17 is equal to 16. So in the first case, your remainder is minus 1. In the second case, your remainder is minus 2. Like I said, minus 1 is basically 17 minus 1, 16 is the remainder. You can write 16 into 15 as a remainder, or you can write minus 1 into minus 2 as a remainder. Both will give you the same thing. This will remain as is, and this is what we'll figure out. So this is nothing but 2 into remainder of 14 factorial by 17 equal to 16. So then I can write 14 factorial by 17. It's nothing but 16 by 2 or 8. So 8 is your answer. So basically what we did break down 16 factorial into 16, 15 and 14 factorial. And then from there, we were trying to do 16 separately, 15 separately, and 14 factorial. I keep it as is and then calculate the value of the others and then get the answer. Okay. So the next problem, 34 factorial to the power 38. Now again, there are two parts to it. See, one way you can identify there is a power, which is like in the previous problem when we solved this m to the power n minus 1 by n. Okay. So here the power was -1. And then we solve this factorial wala theorem, where n minus 1 factorial by n is n minus 1, right? So we solve both of this, but let's see what is the current one talks about. So this talks about find the remainder when 34 factorial 38 is divided by 37. So we know that 34 and 37 are also co-prime, so they can apply the theorem, and 37 is also prime. So I can use both the formula actually if I need Fermat's and the Wilson's, the second last one and the last one, both formula that we have seen, we can apply both. Okay, so let's first start with 34 factorial by 37, how we can get it the same way we got the 16th one. So I can write 36 factorial by 37. The remainder of this will be 36. And then again, I can break it to 36 into 35 into 34 factorial by 37 is equal to 36. Now, in the first case, I'll get a remainder of -1. In the second case, I get a remainder of -2. And the last case will remain as is 34 factorial by 37 is equal to 36. So then I can write remainder of 34 factorial by 37 is 36 by 2 or 18. So can I write remainder of 34 factorial whole to the power 38 by 37 is same as reading as remainder of 18 to the power 38 by 37? Because 34 factorial by 37 is nothing but 18. Now, if you keep writing 34 factorial to the power 38 means what? 34 factorial to the power 38 means 34 factorial written 38 times. So each of the time, if I get 18 as a remainder with 37, then I get 18 to the power 38 as a remainder, right? Now, I know 18. If I consider my 18 is my m and 37 is my n, now I know remainder of m to the power n minus 1 by n is equal to 1. If m and n are co-prime, so 18 and 37 are co-prime, so I can very well apply this Fermat's theorem, again the second last problem form theorem. But power has to be n minus 1. So can I write this as 18 to the power 36 into 18 square? So this by 37, right? So in the first case, I get a remainder of 1. 18 to the power 36 by 37 gives me a remainder of 1. Okay. Into remainder of 18 square is 324. 324 by 37. If you do it, you get 28 as a remainder. 1 into 28, your 28 is the final remainder. So in the first part, 18 to the power 36, I get 1 as a remainder. 18 square by 37, I get 28 as a remainder. So 28 is the final remainder. Go to the seventh problem. It says 1 cube, 2 cube, 5 all divided by 7. Let's see. 1 cube, 2 cube, 3 cube till 20 cube. Now, if you identify carefully, divide by 7. So you need somewhere a plus minus 1 of 7 or a power multiple of 7. So if you see this, can I write this? Then this is a cube. So if I take 2 cubes in a group, one with 2, I'm trying to get 21. So 21 is a number divided by 7. So a lot of number system problem is go by that initial hunch and you try to triangulate the question to solve around your hunch. So I have a hunch that 1 plus 20 is 21, 2 plus 19 is 21, 3 plus 18 is 21. So everything is kind of giving me a particular answer. So 2 cube plus 19 cube. Keep on doing this. I'll last get a 10 cube plus 11 cube. So 1, 22, 19, 3, 18, 4, 17, like that I'll get till 10 and 11, right? So there are 20 numbers, so I can easily create a 10 groups. So if there was one more number, that you have to keep it separately. So understand this part. If there is a 21 cube separately, that you have to keep it separately. Or if there are odd number of numbers given, then one number cannot be part of this pair. Each it cannot be part of a pair and has to be considered separately. But here there are 20 numbers, so I can make them as a pair of 10 numbers. 10 pairs, pair of 2. And so the first one, 1 cube plus 20 cube, if I have to write this, yeah. So I can write this, and the first one is 1 plus 20 into 1 square plus 1 into 20 plus 20 square, the normal a cube plus b cube formula. Then the second one, 2 plus 19, 2 square, 2 into 19 plus 19 square, and so on. So everywhere you will see, you will have a 21 here, you will have a 21 here. So every value, even in the last value, 10 plus 11 is 21. So all of these are basically then divided by 7. This part is also divided by 7. This part is also divided by 7. So all the simplified form of these cubes are divided by 7, because everything has a 21 as a plus b. So then the remainder will be 0. Okay. So that's about it. So we solved around 7 problems today, and hope you can solve around at least 20 problems at home, so that you can get complete mastery of this. And going back again, I'm repeating, go through all the concept videos, all the problems, see all the type of problems that we have solved in the last 4 sessions, and solve 3x amount of problem at home. Any problem anywhere you find, whether I solved or you are getting stuck while you are solving, please feel free to reach out over the mail, or you can drop me a comment and we'll be able to take it further from there. Okay. So see you. Hope this session is helpful. Please like, share, subscribe to it, and yeah, see you next time. Thank you. Bye.